All right.
Start?
All right.
Awesome. Well, thank you so much, folks, for joining us. Thank you for giving up on your happy hour today. Day 1+2 of reInvent. I'm Alex. I'm a networking specialist solutions architect with AWS, and I'm accompanied today by Andrew.
I'm Andrew Graham, a principal solutions architect as well, networking specialist.
Yeah. And we are going to be talking to you folks about all the new feature capabilities launches that happened across AWS networking throughout the past year, and all the cool new architectures that you can build with them. But before we begin, this is a 300-level session, so we will go fast. We will go deep in some areas. We will go wide as well, because we do need to talk about all networking services, right? We will let you know when animations end so you can take a photo of the slides. We know that everyone loves taking photos, so you will see that icon on slides, and you'll see when to take photos. And Q&A, as I mentioned, is going to be after the session, so keep that in mind, not during our session. Now, as you folks are accustomed to, we're going to talk a bit about foundations so that everyone has the concepts and knowledge about all the things that make up AWS networking. And we're going to start with the AWS backbone, the AWS global backbone made out of regions, availability zones. These numbers, I'm hoping they're still up to date since this morning. The coolest number there is more than 9 million kilometers of fiber. So that's pretty impressive. And this is what powers what helps from an infrastructure perspective host all your workloads in AWS, right? From a hosting perspective, right, you have your Amazon VPC, which is hosting your compute, your workloads, your instances. Amazon VPC is a regional construct. And within the Amazon VPC, you can spin up subnets that are those containers for your workloads. Subnets can be IPv4, can be IPv6, can be dual stack, and they are AZ-level constructs, right? So per availability zone. Now, from a security perspective, at the VPC level, you have network access control lists, which are subnet-level access controls, stateless firewall filtering, and you have security groups, which are your stateful firewall filtering. Last but not least, you can insert AWS Network Firewall in the picture to get you traffic inspection, decryption, advanced filtering controls for your traffic. Now, from connectivity perspective, if we go and we look at VPC connectivity, you have internet connectivity with the help of the internet gateway and the egress-only internet gateway. And of course, you have IPv4 and IPv6 flows and constructs that help serve each and every one of them. From an IPv4 perspective, you have the NAT gateway, which is a regionally available construct, AZ-level deployment. And for IPv6, to accommodate for the same type of egress-only flows, right, that don't accept ingress, you have the egress-only internet gateway. Now, if we go towards application scaling, because it's not just about application connectivity, but application scaling as well, our Elastic Load Balancer suite encompasses 3 load balancers: application load balancer, network load balancer, and gateway load balancer. We're going to see those deployment models in a bit more in depth. Now, if we are to talk about connectivity to AWS services, we have AWS Private Link, which gives you 2 types of endpoints in your VPC. Gateway endpoints do not have interfaces in your VPC. They connect to S3 and DynamoDB, while interface endpoints, they have interfaces in your VPC. They're deployed in a subnet or a set of subnets in multiple availability zones, and they require you to update DNS. Right? There's no routing updates, as in the case of gateway endpoints. Now, from extended application connectivity perspective, it's not just about connectivity to AWS managed services, but it's also connectivity to your own application, so app-to-app connectivity. Here's where Private Link started the capability of supporting customer managed services, and you can have this capability both within region and across regions. We launched that last year. And if we go towards application connectivity at scale, here's where Amazon VPC Lattice comes into the picture with a scalable, highly available, managed service for that. which allows you to connect to your service network, services and resources in a secure manner using auth policies. We're going to dive a bit deeper into Lattice and into reference architectures with this. Now, if we step down from the application level and we go towards connectivity at the network level, right? We have various options for you to connect your VPCs on AWS. The first one is VPC peering, and you can have this intra-region and cross-region as well. VPC peering is not extremely scalable, so from a routing perspective, you can scale your VPC connectivity in a region using AWS Transit Gateway, which is a regional routing hub that allows you to connect many VPCs in a region, up to 5,000 public-facing quota, and allows you to also peer multiple transit gateways together, intra-region and also cross-region. Just keep in mind that transit gateway relies a lot on static routing, right? So it's not an intelligent, dynamic driven router or routing hub in AWS. Now, if we do want that dynamic global connectivity and we do want to expand across multiple regions, AWS Cloud WAN is here. And we actually got a question last year around, it's still not clear for me what's the difference between Cloud WAN and Transit Gateway. That's not the big difference, actually. The Cloud WAN comes as a fully managed service that's globally, extends globally, it's globally available, and that allows you to have this dynamic connectivity across segments. That is a fully managed type connectivity. You don't have to manage static routes. The intelligence under the hood is attached to core network edges, which are like transit gateways, right? So you can choose. Transit gateway is a DIY type service. Do it yourself. You can configure routing and static routes, whereas Cloud WAN is your global fully managed service. And we're going to dive a bit deeper into it today. Now, not all workloads live in AWS. And if you folks are familiar with some of the recent launches, you will see that not all workloads, not just that live in on-prem, but they also live in other clouds, and we're going to talk a bit about that. From a hybrid connectivity perspective, we have site-to-site VPN, which is our IPsec-based VPN connectivity method, and Direct Connect, which allows you 3 flavors of virtual interfaces: private virtual interface, transit virtual interface, and public virtual interface, right? Now, from a remote access perspective, to give remote access to your end clients without a VPN, right? That's the whole point. You can use AWS Verified Access, and you can integrate this with device management, device posture, and identity for your end workers, for your end users to access your public-facing resources on AWS, including that authentication authorization piece, right? Now, all of this is foundations, and we've talked through them. There's been a lot of innovation in 2025. Andrew, take us away.
All right, thank you. So we're going to break off these innovations in a few different sections. So the first one's going to be Amazon VPC. So obviously, we do a lot of development work across many different parts of it. So let's start with internet connectivity. So we talked a little bit at the start about this, and we have our standard VPC here. We've got some EC2 instances. We've got our NAT gateways. This is how you've been configuring NAT gateways for quite some time inside AWS. We now are launching NAT gateway in regional availability mode. What does this do for us? It makes configuration and maintenance and supporting these much simpler. So now, instead of having one NAT gateway per AZ, which we call zonal NAT, you now have this regional construct. It doesn't need to live in its own subnet. It doesn't need to do any of the additional bits. And it updates itself automatically. So if you go through and you add an additional AZ, regional NAT gateway expands for you. It also has some additional benefits in terms of scalability, the public IPs. So this is the construct that we see people going forward with, especially as you're going through new deployments and that sort of thing. In the security front, we have had for quite some time here network firewall. So we've got again, our typical architecture here. We've got some EC2 instances, and we're pointing them up to the network firewall endpoint. If you haven't worked with network firewall before, it's based on gateway load balancer. So we have the endpoints, they go over to a network firewall object that AWS manages, and then you can send the traffic on out. Here we're showing it with regional NAT gateway. So that's fine, but now we are supporting multiple VPC endpoints. So in the previous diagram, we had everything inside one VPC, but now we can have multiple VPCs all come back to the same network firewall. Why would you do this? It makes it so you have one single network firewall policy that controls a number of VPCs, and we recommend customers doing that, but still consider, do you want to split it up by prod, by dev, by whatever security segmentation that you want to do? And if you don't want to separate out the network firewalls, which you might not want to do if you're in a test environment and you've got thousands of these, you can still reference the individual endpoint inside your policy. So you can still get that segmentation that you may need for smaller grained usages. Network firewall itself has had a number of upgrades and improvements launched in the past year. The active threat defense is pretty interesting. This is where we are enabling some of the AWS intelligence to be brought into your network firewall, so you get to see all that. But you can also pull in partner managed rules. So this is where you can reach out to another security partner and have those rules get automatically updated into your firewall as well. Number of console and monitoring and all sorts of additional features there, and feel free to go read the many blog posts that we've launched about network firewall on this one. The big one though is proxy. So network firewall proxy is exactly what it sounds like. So for the longest time, if customers wanted to have fairly controlled access to things like external websites, they were deploying their own proxies, whether it's Squid, who knows what. Managed firewall proxy is now where we provide that service for you. So how does this all come together? It looks very similar to a network firewall deployment. We now have a proxy endpoint. It goes to a proxy instance that gets tied with a NAT gateway. And this is all an explicit proxy. What do we care that it's an explicit proxy? It means you don't need to change the route tables. You're configuring the clients to use this proxy explicitly. So this makes it a much simpler configuration deployment. Of course, this all works with various levels of inspection. So for those who may or may not be familiar with proxy, the client, like I said, will connect up. We can do pre-DNS inspection, which is where we process the rules against something before any kind of connection goes out. Pre-request, we can do post-request, and we can also tie this in with PCA, and this allows us to have it handle TLS traffic as well. So this way you have the clients trust the root certificate over on PCA, and your clients can work with this as well. The overall packet flow on this one, like I mentioned, the clients will do its proxy connection setup to the gateway, and you do that HTTP connect, that's part of the proxy protocol, and there's where you send in the host that you're connecting to, and this is where we do that first step of inspection. Assuming that passes, then the proxy will make the outbound connection for you, and then your client can do the individual request. And this is where the request policy comes in. So you can do things like say, hey, you're allowed to get to here, but maybe not post, or whatever you want to do, or you can get / but not a subdirectory, whatever you want to do. Assuming that passes, proxy will send the request out, we'll get the response back, and we can inspect it again. So you can do things like say, hey, I don't want requests or responses with the word "the" in it, or whatever you want to do. And then assuming that passes, it all comes back to the client. This diagram does assume you've configured the TLS inspection component that we mentioned earlier using PCA. Otherwise, the traffic is encrypted and you lose a couple of those capabilities because we can't see inside the encryption. So as before, we mentioned each VPC can have its own configuration and endpoints in a distributed environment, but much like what we just did with firewall, you can have distributed endpoints that all come back to the same proxy. So this is very useful if you have a use case where you want to keep your VPCs completely isolated. You don't want them to have any kind of attachments or internet gateways or anything else, but you still want to have just a modicum of external access to get to things like package repositories or update repositories or things along those lines. You can, of course, make this part of a hybrid environment where you have Cloud WAN or Transit Gateway providing your interconnectivity services, and then you put the proxy firewall endpoint in a centralized VPC. We see customers using this if you're in a position where you already have a central VPC where you're putting all your networking resources, or you just want to keep the client VPCs as clean and simple as you possibly can and let all the messy networking bit happen elsewhere. Next bit is VPC Route Server. This one is an interesting launch, and what it gives is the ability for instances inside your VPC to make BGP-based routing updates to your VPC routing table. Why would you do that? You can do a number of different things with this. We've seen customers doing any kind of anycasting or making their own failovers or anything along those lines with that. This plays in with a couple of the other features that we'll talk about here in a little bit, but it's kind of an interesting service that fits in a nice little niche. One of the use cases that I mentioned is the floating IP. So in this particular case, we've got two EC2 instances, active standby. We're all networking folks. We love active standby. Well, we tolerate active standby. And in this particular case, we've got a IP address that is not part of our VPC, but it is still being routed up to our active instance. Our active instance goes away, and we can, through Route Server, push out that update and send all the traffic over to our other instance. So we've talked a lot about some of these interconnects, and just to come back to this, Transit Gateway, V4, V6, this has been our deployment model for quite some time. You've got a central Transit Gateway route table, you're sending all your traffic to the various attachments. That's just been the way we've done things forever. But it does make things a little complicated when you want to start adding in firewalls to it. So here we have two VPCs that are connected together by Transit Gateway, and we want to add in inspection. Well, the way we've had to do that in the past is we create a new VPC, a security VPC. We attach that to Transit Gateway. We set up some route tables. We set up some endpoints. We set up some ENIs. We set up some more route tables, all that good stuff. You don't need to do that anymore. Now you can do network firewall as a native attachment to Transit Gateway. This spares you the time and effort to maintain, build, and deploy that separate inspection VPC. You can just tie to network firewall directly, and we handle all the bits and pieces inside for you. Next up is on Transit Gateway. One of the problems that we frequently have heard from customers is Transit Gateway is frequently on a sender pays model. That works for a lot of cases, but not in all of them. So now with Transit Gateway, you can do flexible cost allocation. What does that mean? So you can do things where the traffic flows that Transit Gateway is doing the data processing for can be billed either to the source, the destination, the Transit Gateway owner, and this can potentially help settle things like if you're having to do back charging between different departments or anything along those lines, where you're trying to understand the true cost of a workload. You can then put all the data processing charges assigned to that workload to make that math easier. VPC security, Alex talked a little bit about this at the start, but we're back here with our private subnet, public subnet. We've got NACLs. We've had NACLs for a very long time. We've got security groups. So NACLs, or network access control lists, they're primitive there. They're on the subnet boundary, but they're rather limited in terms of you can only have 40 rules. That's where security groups come in at. Security groups now work, or always have worked, on an individual ENI basis and allow you up to 1,000 rules. So customers use this for application or microsegmentation, any number of reasons. So one thing that we talk about a little bit, and I hit the next, there we go, is security group referencing. So security group referencing, if you haven't used this before, is a feature where you can say instances that are assigned to one security group get referenced in another one. So we recommend customers do this, for example, if you've got your database servers. You can say, hey, everything that's in the security group, that's my web front end, is allowed in on this port. That way you don't need to go through and update additional security lists or what have you. It's all propagated automatically through AWS. The other question that we get a lot is encryption in transit. A lot of customers are worried about, hey, what is going on actually inside AWS? Is my data in the clear? Is it not? And we're very open about that. You can go to our website, you can read all the policy documents, the standards, all that good stuff. But for here, we're going to simplify this down and focus purely on our instance to instance. And here we've generally said, hey, we've got AWS Nitro. Nitro handles encryption between Nitro instances. Great, perfect. This does work in the same region, cross VPC peering, even better. But the problem comes in when we start talking about other things. So for example, what happens if we have non-Nitro instances? What happens with Transit Gateway? What happens with everything else in load balancers? Now we are giving you a control called VPC encryption controls. This one is really, really nice from a few different aspects. So with VPC encryption controls, what you can do is you can put your VPC into two different modes. There is a monitor and an enforcement mode. So in monitor mode, you can turn this on whenever you'd like. And inside your VPC, if you go look at the console, it'll tell you everything that's non-conformant. And you can sit there and mitigate. You can say, hey, I'm going to make an exception because this is an internet gateway. It doesn't make sense for it to have the transit encryption. Or I understand this, or what have you. But that monitor mode gives you a chance to dry run it first. In addition, inside your VPC flow logs, we now add in an additional field. We tell you if it's Nitro encrypted, if it's application encrypted, or neither, or both. So monitor mode's great, but then after you go through and you mitigate everything, then you can turn on enforcement mode. And what enforcement mode does is it ensures that you can't launch anything inside your VPC that does not support encryption. Fantastic. Makes it so we don't have to worry about these types of questions any longer, like, oh, is this path encrypted? Is this one not? It's all encrypted at that point.
Cool.
So I've talked a lot about networking at this point. So you want to talk about applications?
For sure, for sure. And with application networking on AWS, application owners and network owners and security owners have started to come closer and closer together. Now, part of the application networking suite on AWS are a few services. We're going to start with AWS Private Link and connectivity to AWS Managed Services. We did go a bit through this at the beginning, where you have private link endpoints in the form of gateway endpoints or interface endpoints, and connectivity to AWS services translates into a DNS change in your VPC on the Route 53 resolver. Now, from the gateway endpoints perspective, these don't require any DNS changes. It's only a route in the route table, right? Now, very exciting launch. We've worked with a lot of you with feedback from last year's launch around support for cross-region private link for custom services, and now we support cross-region private link for AWS managed services. How does this work? Well, very simple, straightforward, exactly as you would expect it. You can now create interface endpoints in your VPC in a different region for AWS services that are in cross regions. You have full control over which services you allow to be created across regions, and you can control that at the AWS organizational level. Very important. Now, the other thing that I'm very, very excited about, and some of you have already mentioned that you're going to receive stickers only if you adopt IPv6. That's not true. It's comprehensive IPv6 support. And we've launched IPv6 support for gateway endpoints for S3 and DynamoDB, as well as for interface endpoints. So there's no more excuse to not adopt IPv6 now. The second service in our application networking stack is Amazon VPC Lattice. And this is purpose-built for internal application-to-application connectivity on AWS. And I want to go through a bit of history here, right? You as developers, as application owners, you have your services, right? You have your applications that are deployed on certain compute types. And you can have a bunch of various services in your environment, right? We didn't actually use those services, by the way. They're just made up. We didn't have a Lambda function generate our stickers. In addition to services, you can also have data sources, resources, TCP applications, right? And the idea is, from your perspective as a developer, what you want is certain things to talk to each other, certain things not to talk to each other. Mostly security wants certain things not to talk to each other, right? These applications that you own are hosted either in VPCs, or if you run Lambda, you can host it in Lambda, not necessarily to have it in a VPC. VPCs are your network level boundaries, but they don't help you that much express that intent for, hey, A needs to talk to B and C needs to talk to D. So here's where Amazon VPC Lattice comes in. In VPC Lattice, you have a couple of constructs that I'm hoping everyone is already familiar with by now. You have VPC Lattice services, which are your HTTP, HTTPS type applications. So layer 7 application layer. And you have VPC Lattice resources, which are your TCP applications. TCP applications that could be databases, for example, but could also be just simply applications that listen on a TCP port that are not HTTP level applications. Now, I talked a bit about intent, and I talked a bit about saying, okay, how do we bring these things together to talk to each other, right? This is what the VPC Lattice service network comes to offer, right? It's a logical boundary that helps you bring together things that need to talk to each other. A super common question that I'm getting is, should I have just one Lattice service network? The answer is no, you can have as many as you want. Just design them in a way that makes sense for you, keeping in mind that principle, things that need to talk to each other. And how do you express that intent in Lattice? Well, through associations. Everything in Lattice is an association from this perspective, right? And you can associate services to a service network, right? So you have service associations. You can associate resources to a service network, so you have resource associations. You can associate VPCs to a service network, and you can associate service network endpoints to a service network, right? If you go into the console, you'll actually see all of these names as associations. Now, these two types of associations for VPCs or service network endpoints and for services and resources give you the path to either be consumed if you're a service or a resource, or to consume things, right, if you are a client in a VPC. Now, really interesting and important are the auth policies in VPC Lattice, which are IAM-based and allow you to control granularly exactly that intent, right? To say A should talk to B, but B should not talk to C, right? These are baselines. And at the end of the day, from a developer perspective, this is what you need, right? You need the ability to have your applications talk to each other. If we are to dive a bit deeper and to look at some of our services here from a client service perspective, the whole communication path starts with a DNS request, right? You as a client service or the client service is trying to access a service by doing a DNS query, and the answer to that is VPC Lattice IPs. That's what draws traffic to the service network, right? Instead of routing it to, I don't know, your VPC peering or transit gateway or cloud WAN, right? And in order for this to happen, you have to manage DNS, right? So you have those private hosted zones associated with your VPC that tell you those custom names and how they're mapped to the VPC Lattice generated FQDNs. But very exciting launch to simplify how DNS management works. We now support custom DNS for resources, which means that when you create a resource, right, you can now define a custom DNS for that resource. And it means that you don't have to manage private DNS anymore, private hosted zones associated to client VPCs, right? So let's take, for example, my resource here, new features update for reInvent 2025. I've defined this as a custom domain name. And now I have the level of control, both at the resource association to the service network, at the service network level, and at the client level, to propagate that DNS private hosted zone, right, into the client VPC. So from the client perspective, there's nothing that I need to configure anymore on the VPC for DNS management. It all works. And keep in mind, For those of you who are security conscious and need to control how these private hosted zones are propagated, that the service network level DNS manipulation and the VPC, client VPC, are always under your control as the owner of those resources, right? Cool. And a second very, very important improvement in VPC Lattice is around configurable IP addresses for the resource gateways. By default, your resource gateways would take a /28, oh, sorry for that, a /28 per availability zone to use for traffic to your resources. Now you can specify how many IP addresses those resource gateways have and what are those IP addresses. Let's go towards advanced architectures because these are constructs that all of you have been familiar with for quite some time. And here are some of the most interesting ones. First, when do you use SNA versus when do you use SNE? SNA, Service Network Association, SNE, Service Network Endpoint. The difference between them and when you would use them is exactly like the difference between an S3 interface endpoint and an S3 gateway endpoint. The gateway endpoint cannot be accessed from outside of the VPC, same as the Service Network Association. The Service Network Endpoint can be accessed outside of the VPC, so that's when you would make the decision of using that. Now, the second one is providing connectivity to applications that are on premises, right? So your applications are on AWS, and you want to bring into Lattice some applications. How do you do that? Super common scenario is to have a transit VPC. For those of you who've been around before 2018 when Transit Gateway was created and launched, it's not that transit VPC. There's no BGP here that you need to manage. It is a transit VPC in the sense that it has IP addresses that are routed towards on-prem, right? So they're non-overlapping. Everything to the left of that VPC can be overlapping, right? Because Lattice accommodates for overlapping IP addresses. So you have to have that transit VPC with a resource gateway that allows you to target these resources on-prem. How do you bring them into the service network? By means of resource configurations. And on resource configurations, we support custom DNS names. Hence, you can give them your custom names that are used by your developers for your on-prem resources. Now, if we are to dive a bit deeper into the other flow, right? You may ask, well, how do I do the other way around, right? I have a client on-prem. How do I get it to be able to talk to these resources or services that I have on AWS? Well, the Service Network Endpoint provides you with an FQDN for every single resource or service that you have associated with your service network. And if you take that FQDN and you map it into your DNS configuration on-prem, you could have an inbound resolver endpoint if you wanted to in that VPC, or you could have, I don't know, hosted zone delegation towards your on-prem DNS servers. You can absolutely make sure that that DNS name is used by your clients on-prem, and everyone talks to that service network endpoint. And also keep in mind that both on service network associations and service network endpoints, you can configure security groups, right? So you can filter what traffic can get to the service network endpoint. Another interesting one is that this service network endpoint is a layer 3 construct, right? So it has ENIs in your VPC. A super common question we get is, can I put a firewall in front of that? Yes, you can absolutely do that if you want to. But keep in mind that you have the auth policies in Lattice, right? So make use of those. There's no data processing cost for auth policies. There's no hourly cost for auth policies. So make use of them. And most importantly, do you need to use SIG-v4? So do you need to use IAM roles and sign your traffic to be able to use auth policies? The answer is no. You can use auth policies even if you're not signing your traffic. You won't have the principal ID as a condition key in the auth policy, but you can still have condition keys like source IP, right? Or source VPC or source account. So keep that in mind. Now, another interesting architecture that we've been hearing about a lot and customers have been trying to build it is cross-region service-to-service communication. right? Lattice doesn't currently support native cross-region services or VPCs or resource attachments. So you do need to have this transit VPC that brings you layer 3 connectivity between the regions. And these are the only 2 VPCs, or if you have many regions, 1 VPC per region, that have to have non-overlapping IP space, because these are the ones that connect to each other in your layer 3 domain. Now, in each region, you have the service network endpoint, which gives you layer 3 ingress into the service network. And in the opposite region, you have resource configurations, right, that are targeting the services or resources in that remote service network that you want to bring into your region, right? And you can use custom DNS to have everything managed from a DNS perspective. Centralizing private link endpoints. How many of you are doing that today with Transit Gateway? Probably a lot, okay? You can absolutely do that with VPC Lattice, and you can actually have DNS managed for that, for all your client VPCs, because of custom DNS on resources. So every endpoint is actually a resource in VPC Lattice. Now, how many of you folks are consuming SaaS provider endpoints? Probably a lot of you, right? Can you centralize SaaS provider access? You can absolutely do that, right? You can have resources that point to VPC endpoints for SaaS providers that you want to offer to your clients. And very, very important, can you inspect that traffic, right? Can you inspect the traffic that's going towards your SaaS providers, and can you do traffic filtering? The answer is absolutely yes, you can. The resource gateway is a layer 3 construct in your VPC that has elastic network interfaces. So if you put a network firewall in there and you configure routing appropriately, your traffic will be inspected through the firewall, right? From the resource gateway towards the VPC endpoints for your SaaS. Pretty cool architecture, and it's actually used by many of you. Now, from a seamless integration perspective, I don't know how many of you know, but Oracle Databases at AWS does rely on VPC Lattice for exposing services and resources to your Oracle database deployments. So that's a cool one. But not everything is about service-to-service connectivity. So, Andrew, elastic load balancing?
Sure. So, what was mentioned earlier, where we have the different load balancers, application load balancer is one that handles all of our layer 7 work, so HTTP, HTTPS, and it has had a number of new launches in the past year. So out of all of these, the ones I like the most are the target optimizer, because this has been a frequent request from customers to say, hey, I want my ALB to actually load balance based on the number of concurrent requests. So you may have some requests that are short, some that are long. ALB will now manage between those for you and help keep that load more evenly distributed in those kind of workloads where you've got different response times. The other one, the health check logs, this has been a very frequent ask to dump what is ALB seeing in terms of all your clients. Now you can store that in an S3 bucket, and that is actually free of charge besides the S3 bucket fees. So that's something you can go in and just turn on, and then you keep an audit. What happened to each of my targets? What was the response code? All of that. So you can go back and see, is everything doing well? Did I have problems? That sort of thing. ALB has also introduced some post-quantum key management. So you'll see that is fairly frequent now across a lot of different AWS services, but it's worth mentioning here.
We always say that we will be ready for post-quantum before you folks need to think about it. So this is that.
The other load balancer that we tend to talk about in the same breath is network load balancer. This is our TCP/UDP one, and you'll notice there's some similarities here. So access logs can now be vended out. The one I like here, though, are the weighted target groups. So the use case for this one is you can do things like, hey, I've got a bunch of fairly powerful instances that cover my base load, but then I want to come up with very, very small ones in my auto-scaling groups. So you can assign the weights on those lower and have NLB properly manage that. Again, we've got some post-quantum stuff here that everybody likes to see. But the bottom one is really interesting as well. NLB now supports QUIC, which is sometimes called HTTP 3 or some different acronyms, in pass-through mode. So what this does is this leverages a IETF draft where you encode the server ID inside the quick connection ID, and NLB will use that to guard its or make its sticky session decision. Amazon API Gateway has also gained a very interesting feature called the Developer Portal. Developer Portal basically does automated work to pull in all your various APIs, your services, and put them together in a portal for you. Previously, you would have to do this by hand or create your own automation or however you want to do it. But now this is a fully managed solution. It pulls in your APIs. It can do, and it's very, very customizable. You can go in and play with the colors or names or certificates or whatever you want to do. And you can also put in the access control that you've come to expect from most AWS services backed by our normal identity services. From API Gateway, we have a couple other bits and pieces here. The response streaming, this has been an ask in order to improve the time to first byte. That's what TTFB stands for on there. Where we've also extended the response timeouts to 15 minutes, payloads larger than 10 megabytes. People seem to love using API Gateway for very, very large things, so this got implemented. More TLS security policies. You can now integrate API Gateway with private ALBs, so this helps a lot from a security perspective. And you promised no AI mention.
I said we're not going to talk about AI, but we have to mention this through Agent Core.
There's MCP support in API Gateway. We're just So let's get out of that and let's talk about global and hybrid connectivity. And as we've talked about a couple times, the first one is going to be Cloud WAN. So Cloud WAN, we mentioned earlier, all the foundations. You start with the core network, which is the container for everything, and then you expand that into each of the regions that you're interested in, and Cloud WAN deploys a core network edge. Once you've done that, you can see this all in a JSON policy file. And we're going to keep coming back to this concept because everything in Cloud WAN is defined in a JSON policy file. This is great from an auditing perspective, from seeing what the differences are. You can do policy rollbacks inside the UI. And what we found is, especially security folks, love having a single document that says, hey, these behaviors are what's being actually implemented. You can put some human names in places, things like that, and your entire policy is in one place. Very easy to audit, very easy to control, very easy to understand. So as part of that, the next item inside Cloud WAN are network segments. Network segments you can define to be anything. We've got customers that do it by security zones, by regions. Some customers are doing it for where they have different policy domains or different legislation that they have to obey, things along those, but it's completely up to you. Cloud WAN supports a number of these segments, so feel free. We've got customers that are kind of doing every combination you can imagine. What connects into a network segment? Well, you can connect lots of things into a segment. The first one, of course, is going to be VPCs. VPCs attach into a segment, and that is controlled by a tag that you put on the attachment. So again, easy to audit, control. You can be assured as to where that is going. So now, if you start doing this multi-region, this is where Cloud WAN's other big feature comes in. It is global. So the same policy applies worldwide. You don't have to worry about any additional replication, anything like that. It's all global. So your VPCs here, you've got the same policy here. We're saying, hey, some of these VPCs attach to segment A, some segment B. They get the same behavior worldwide without you doing anything additional. You can also connect in what we call tunnelless connect. So we've had a number of features in the past that were tunneled in one way, shape, or form, whether it's IPsec or GRE tunnels or what have you in order to do dynamic routing. You no longer need to do that with Cloud WAN. You can create just instances that are speaking BGP to Cloud WAN and control the route tables that way. Again, you can use this for things like different services. I've seen customers using this for logging and other kinds of failover. Like, this guy's kind of the limit here, but it's been a lot of interesting use cases that have come up from this. The next thing that you can add into Cloud WAN is Transit Gateway. And one of the biggest questions I usually get is, does transit gateway have to go into one segment? No, it is determined by the transit gateway route table, not the transit gateway as a whole. You put in an entry in the route table, you say go to this segment. So this means that you can still maintain some control at your transit gateways, whether you're migrating to Cloud WAN or you're adding it in, you're using Cloud WAN for global, transit for local. Use whatever makes sense for you. But this capability makes it so you don't have to worry about, oh, do I have to dump my entire transit gateway into one segment? No. The next thing that you can drop into a segment is, of course, a direct connect gateway. So this is where, obviously, your DX links come in and your external connectivity, and this comes in as yet another attachment. I will say I do see customers frequently creating their own segment for DX, call it external, call it on-prem, call it what you will. That is very, very common. But again, you gain BGP routing capabilities. So BGP routes get advertised in via your direct connect links. You can work with them inside Cloud WAN. You can, of course, connect in multiple direct connect gateways, and customers will do this if they've got things like they want to advertise the same blocks, or they want to go, there's a few other advanced architectures where this may come in at. A little more common, though, is where you have multiple direct connect gateways tied into multiple segments. So this would happen if you've got, for example, a prod and a dev on-prem, and you want to tie them in to their respective segments inside Cloud WAN. Cloud WAN now supports security group referencing. So we mentioned that earlier. It now works inside Cloud WAN as well. So inside Cloud WAN, you just toggle a switch. It says, hey, you're allowed to do these references. And like I mentioned before, you can have a security group that controls your instances in VPC-A, and you can reference it in what we're calling security group B here. Like I said, my use case is micro-segmentation, but it's also very, very helpful for if you've got security folks that are like, oh, I don't want you opening 10/8 or giant blocks. Now you can say, okay, only the instances that are assigned to the security group can access this. Very helpful from a security perspective. So this is the feature I'm personally most excited about in terms of Cloud WAN. I came from native routing. I worked with routers for a very long time. So advanced routing controls really kind of scratches some of those itches that we've had from customers saying, oh, this is all great, but I need more control. I need more capabilities. I need to be able to do really fine-grained controls with this. So advanced routing controls gain you a lot of features. You can do route filtering now. So you can say, hey, this VPC doesn't need these prefixes, or I don't even want this space routed to this VPC. You can do that. You can do, between segments, between this and on-prem. You can configure summarization. You can configure path manipulation, and we'll go through an example of that here in a little bit. But if you're used to your normal routers, your physical devices, this is very similar to route policies or route maps or whatever you want to call them from your vendor of choice. You now gain a lot of those same capabilities inside Cloud WAN. What does that look like? So inside the console here, and we're going through the console, but remember, you can do it in JSON as well. You create a routing policy, and it'll ask you a few very straightforward things. Assign it a number, assign it a name. Is this going to be inbound or outbound? All fairly straightforward questions. Here we're just defining it as 100. And then once that's done, it'll show up inside the console, and now you'll be able to add rules. So inside the rules, you can sit here and click Create a Policy Rule. And this is where this gets pretty interesting, are the various rule components. So again, if you're used to route policies, you'll see your normal, hey, condition, what am I doing with it? Okay, fair enough. So what all can we do here? There are a lot of actions you can take. We can manipulate, we can block, we can allow, we can manipulate AS paths, we can do, well, you all can see the entire list up there. So it's kind of your normal set of things that you're used to seeing from traditional routers, but now it's all being brought into Cloud WAN. What are the conditions? Again, kind of the same thing you're used to. You can match prefixes, you can match AS paths, you can match meds. You can do all this sort of manipulation here, and now you have the capabilities to do so many things. Determine, where are my primary and backups going for remote regions, for example? Oh, I don't want paths from this internal AS to come into Cloud WAN, or I only want these, or whatever you want to do. This feature has a lot of interest from the networking engineers that are been used to that and been kind of screaming at us like, we need more controls. Well, here you go. So, and there's the real example. And like I mentioned, it's all in JSON. So again, the UI will help you create it. But again, once it's in JSON, you can sit here, you can copy and paste, make it a lot easier to make multiples of these. But remember what I said earlier. Cloud WAN gives you the ability to roll back policy versions. So if you make a change you don't like, you just tell it to roll back to the other one, and it changes everything back for you. You don't have to worry about trying to undo things. You don't have to do any of that. You just go back to where you were, and everything's good, and you can try again. So the other part of this is where the routing policies actually attach at. Yeah, there we go. So inside each attachment is sorry, the clicker's acting up a little bit on me there. You define policy tags inside there. You also select what region it is available. And you configure the routing label here. So this label here is just another kind of internal name that you're going to be associating with. You create the network policy there. And now you can go through and apply the routing policy label onto the attachments. So this is that final interconnect piece where you're tying in the policies to specific attachments. Once you apply that label, of course, we will tell you, okay, hey, you applied this label, here's the policy that's getting applied, just give you that positive confirmation that it's doing what you expect it to do. So that's great, but how do I know what all Cloud WAN is seeing and getting? By very frequent and vocal request, we are now giving the rib view. So you can now see all the routes that Cloud WAN is learning, where it's learning them from, all the various information, the AS paths, all that other good stuff that you can now see inside Cloud WAN, including all your backups. So a couple of little minders about the advanced routing controls. There's a few things where it doesn't make sense for some of these things to work on other ones. But generally speaking, this works pretty broadly, and it gives you the capabilities that you're then looking for some of these really fine-grained routing decisions. So I've talked a lot about internal routing. Alex?
We go for hybrid, right? And we have site-to-site VPN and a number of very cool launches about it. First one is high-throughput tunnels. So now you can have up to 5 gigabits per second tunnels, and you can do eCMP on Transit Gateway and Cloud WAN. The Eero partnership was just launched, where you can have Eero devices on your on-premises, and VPN concentrator for a large scale of small throughput VPN tunnels. Really, really important for folks using site-to-site VPN. And for Direct Connect, we've talked a bit about at the beginning around use cases for Direct Connect and how customers are using it for connecting to their hybrid workloads. Very, very cool launch that happened on Sunday is AWS Interconnect Multi-Cloud. There's also another flavor of AWS Interconnect, which is called Last Mile. It's a gated preview with Lumen, so we're really excited about that as well. AWS Interconnect Multi-Cloud is launched in partnership with Google, and we will have other cloud providers coming in 2026. The idea is, how do we provide private connectivity between AWS and your environments and other clouds? Well, before, you had to go cable all those things up. You had to go build your high availability and resiliency using either your own router or a customer router. Now, you just go through the console, and it's just a matter of clicks. Or through automation, by the way, not ClickUps, right? Let's see how that works. Everything is taken care of for you under the hood. AWS and Google Cloud have cabled large amounts of capacity. And what you get is essentially an interconnect that you get to attach to your Google Cloud router on the Google Cloud side and to the Direct Connect Gateway on the left side. There's a lot of deep dives and reference architectures that we've gone through in terms of regional versus global level construct with Cloud WAN. There's a dedicated session for this at reInvent that happened this morning, so you're going to find it on YouTube in about 48 hours. The most important thing here is the collaboration between the clouds. So you interact with each of the clouds, you create an interconnect, AWS and Google Cloud provision that capacity, and everything is fully managed. And you go and you accept the interconnect using the activation key that you're provided, and that's that. That's all you need to do. Under the hood, it is highly available, highly scalable, encrypted connections between the two cloud providers. There's no third party in between. And we're diving quite deep into this in the other session that I mentioned. Now, keep in mind that for preview, you get for free a 1 gig connection. When it is going to be GA, you folks are going to be able to scale up and down capacity to whatever numbers you want. And I mentioned that other cloud providers are going to be coming in 2026. We are working closely with Azure on that. From an advanced architecture perspective, you remember this, right? Cloud WAN or some sort of layer 3 connectivity with VPC lattice, and your resources living on-prem. Your resources could also be living in another cloud, and now through interconnect, you have layer 3 connectivity. Now, a couple of super cool launches that we're going to breeze through. DNS Global Resolver from Amazon Route 53. This is a launch that just happened, I think on Tuesday, we've launched it. It allows you to not have to manage inbound resolver endpoints for your workloads and DNS delegation and so on. It gives you any cast IPs in IPv4 and IPv6 that you can configure on your workforce fleet, on your on-prem devices, and they're fully controlled, fully managed, and secure. So give it a try. From a DNS and content delivery perspective, Amazon CloudFront now supports mutual TLS for clients. It was a feature that was highly asked from our customers. And we've released flat rate pricing without overages for a set of services that customers use for content delivery and website and security and content delivery. So we've created these bundles that you can find on the website, and they are fully managed in this bundle, and you get different tiers, right? From basic to pro, you get to pay a monthly fee without overages, as I mentioned. From an IP address management perspective, IPAM had a lot of cool launches this year. One of the ones that I'm most excited about is the public IPv4 allocation policies. No, it's not IPv6, but still. Here you can integrate with prefix lists, and you have the ability of specifying certain IPAM pools for certain use cases that you want those IP addresses to be allocated. And you can automatically populate prefix lists, for example, to get you started with IP allow listing for your partners, right, for example. And we have a blog published describing that solution, so I would highly recommend you folks go through it. And last but not least, IPv6 adoption. I wanted to call out these super cool stats. So over 75% of AWS services now support IPv6. We are on track to get to a higher percentage by the end of this year, so stay tuned. And 100 plus services launched IPv6 support just this year. So if you had an excuse around, hey, AWS doesn't support IPv6, so that's why I'm not doing IPv6, now's the time to do it, right? Really, really exciting. And for those of you who know how we end this presentation, is usually with recapping all the things that we've launched throughout the year in AWS networking, right? I don't know if you folks have looked at the session last year, but this is how we ended 2024, right? These were the features and launches, all on a big slide that were there for you folks to take away. Now, in 2025, we've launched over 150 features and integrations in the AWS networking space. So are you all curious how this diagram looks in December 2025? Yeah. Well, I am too. This is how it looks like. You have a task. Spot the differences and let us know. And just to call out a few of the ones that we've gone through today, network firewall, proxy, VPC encryption controls, Cloud WAN advanced routing policies, security group referencing on Cloud WAN, VPC lattice, support for custom DNS names and configurable IP addresses on the resource gateways. Route 53, global resolver, bundled pricing for web and content delivery. I don't even know. Did I capture everything?
You said 150 earlier or so, you know.
Because there's 150 plus. Cool. Well, that was it. Thank you so much, folks. Thank you for sticking around with us. Please do fill in the session survey, and please do meet us outside for stickers.